Hi, this video is to talk about the coefficient of determination. Now that you know the two sources of variation, we can use them to determine how much of the total variation we're able to explain. So I'm gonna give you this kind of coefficient here, r squared. Okay. So this r squared represents the coefficient of determination. This terminology is very important. Many problems talk about coefficient of determination, or they show you the r squared. So you have to understand that. And what it means. This means how much of the total sum of square regression that I showed you in the last video. How much of this total sum of square regression is part of the square total. In other words, how much of the total variation the sum of square regression is able to explain. Yet, explaining in a different way, the coefficient of determination is how much the total variability in the model is given by, is explained by our regression model. Okay. So let's take a look at additional information about it. So the coefficient of determination is the proportion of the variance in the dependent variable that is predictable from the independent variable. Okay, so how much of the dependent variable is explained, is predicted, or is predictable from the independent variable is represented by r squared. An r squared of 0 means that the dependent variable is not influenced in any way by the independent variable. An r squared of 1 means that the dependent variable is totally influenced by the independent variable. And also, if, for example, it varies from 0 to 1, this r squared varies from 0 to 1. And an r squared of, let's say, 0.10 means that 10% of the variance in y, the dependent variable, is predictable from the independent variable x. An r squared of 0.2 means that 20% is predictable and so on. Now let's take a look at some problems in MindTap so I can help you answer problems or see how the problems are. So we're here in the coefficient of determination, and let's wait until okay. Coefficient of determination, we have additional explanation. Let's take a look at some problems. So we have the following data that shows the brand price and score. So I believe that score is the dependent variable and the price is the independent variable. Is asking you to compute the sum of square total, sum of square regression, and sum of square error. We are not going to work on that. And let's compute the coefficient of determination. Once you figure out how much the sum of square total and the sum of square regression are, you can compute the coefficient of determination. Let's assume we work through all this process, and then you get a sum of square regression of the sum of square regression is equal to 1800. Sum of square total is 1800 and sum of square regression is 287. If you divide this number, sum of square regression, by sum of square total, we get the coefficient of determination. This is what I told you. Sum of square regression divided by sum of square total. That's 0.84. So 84% of the variance in scores are because of the variance in price. That's I'm sorry, the interpretation. Okay. If you have the data, so let's use this data here. We have again annual sales and years of experience. We have this data. So let me open it, sales and years of experience. Let's use the data analysis tool so you can see where this information is. Oh, sorry, I closed. Okay, let's open Let me enable editing. And okay, so let's use now data analysis tool to find the coefficient of determination. If you go to data analysis, I'm gonna do very quickly because you have seen this before. So we go to regression, okay, and then Y range is sales, X range is years, okay, labels, blah blah blah. Okay, labels, I have to check labels. Okay, it's checked. So the coefficient of determination is here, R squared. So you can see here R squared. So it's 0.90. To understand, to interpret it correctly, we have to determine which one is the dependent and which one is the independent. So the dependent on sales. So we can say that 93% of sales is 9% of the variance in sales is due to variance in years of experience. So this is the interpretation. Here's how you can read it using the raw data, how you obtain the R square that the problem is talking about here. So you understand what this means is that years of experience explains 93% of the variance in sales. So if you're interested in higher sales, you should hire people with more experience, because 93% of the sales is explained by the experience of the salesperson. Okay, so this is one potential interpretation. So you see how to compute by hand when you have SSR and SST. You figure out how to compute using Excel, and when you have the raw data. So here you have the raw data, you can download and compute again using the data analysis tool, and then interpret. Okay, so this is how we're gonna learn, how we're gonna practice the coefficient of determination. We're simply understanding how good our model is in using dependent and independent variable. Okay.